Hello my schoolers, welcome to my school channel. So in this clip, we'll be solving questions number 11 to 30. So be sure to check for the links in the description below to other video clips that solve the questions for this year, 2019 JAMB Pass question for chemistry. So let's go over to question number 11. Which of the following metals is the most essential in the regulation of blood volume, blood pressure, and osmotic equilibrium? So definitely when you talk about osmotic equilibrium or osmoregulation, homeostasis talks about the balance of water and salt, that is salinity, in the body. And the two most important essential elements are sodium and potassium. So in the options here, we have sodium being present. So definitely our answer is option C. So we have question number 12. Which of the following alkaline earth metals react more spontaneously with water? Okay, so at first, alkaline earth metals, they are the group 2 metals. And the more you go down the group, the more you go down group 2, the more reactive they are with water. So the first thing you have to do is to rearrange all of these options according to their position in the periodic table. So that is from the first down the group. Okay, so the first you are going to find is beryllium, okay, followed by magnesium, calcium, then strontium. Okay, so you should know that beryllium does not react at all with water. Magnesium reacts only with steam. It's very, very poor with cold water. Then for calcium, reacts slowly even with water. Okay, so the most reactive that we have here, the most spontaneous one, is definitely strontium, option D, because as you go down the group, the more reactive they become with water. So option D is very correct. Here we have question number 13. Okay, so when chlorine water is exposed to bright sunlight, the following products are formed. Okay, so first you should know that chlorine water is a mixture of HCl and O2 that gives you HCl and HOCl, that is hydrochloric acid and hypochlorite solution. Okay, so when they come together, what is formed is unstable. The HOCl is unstable, that is the chlorate ion there is unstable. So exposing it to sunlight, what you would have as their product will be hydrochloric acid and oxygen. So the correct option is C. Practice, practice, practice. So you definitely need to practice and prepare yourself for your coming exam. So I will recommend to you that you download the Myschool CBT simulated apps for your mobile app, or the Myschool CBT simulated exams for your laptops, which we refer to as the software. So I provided the link in the description below where you can download the Myschool JAMB CBT mobile app or the Myschool JAMB CBT software for your laptops and your computers. Okay, so very well, let's go back to question number 14. Which process or processes is or are involved in the turning of starch iodide paper blue back by chlorine gas? Okay, so first know that the starch iodide paper is actually a mixture of potassium iodide or iodine with starch. Okay, so when you expose it to chlorine gas, this is what the chlorine gas does. It oxidizes the iodide ion to form iodine. Okay, so this iodine in turn gives you the blue-black color that you should get. Okay, so but if you further expose it, it bleaches it to white. So definitely the answer to this is C. The chlorine gas oxidizes the iodide ion, okay, to produce iodine, which attacks the starch to give the blue-black coloration. So don't forget to hit the like button, click on the subscribe button, and tap on bell notification to get informed as we release the next videos. Here we have question number 15. I'm super excited just the way you are. Okay, so which of the following is a set of neutral oxides? All right, so let's go through all of the oxides we have here. This is N2O, okay, nitrous oxide. Is actually a laughing gas. It's used in minor medical procedures to sedate and to relieve pain. Okay, so This is it's a colorless gas, but it has a nice taste, okay? So this is definitely a neutral oxide. This is water, colorless, odorless, and tasteless. And of course, this is carbon monoxide. It is colorless, odorless, and tasteless gas. This is nitrous oxide. This is SO2. This is an acidic gas, okay? This is a neutral. So you can see this combination here is not, all of it are not neutral. This is acidic. Okay, let's look at this combination here. This is nitrous oxide, okay? This is sodium oxide, okay? So this is definitely a basic oxide, okay? So all of this also is a basic oxide. So all of these are not neutral oxide. So we are searching for the options which all of its contents are neutral. Okay, so let's look at this. So this is definitely not a neutral oxide. So if we look at option A, the nitrous oxide, water, and carbon monoxide, they are the neutral oxides. So option A is correct. So now to question number 16. SO3 is not directly dissolved in water in industrial preparation of H2SO4, okay, tetrahydrosulfate 6, by the contact process because, okay, so we should know this, that if you react the SO3 with water, number one, it gives off lot of heat. That is an extremely exothermic reaction. Then again, it forces the sulfuric acid to form some kind of mist, and this mist does not condense easily. And again, even this mist is highly corrosive to the lead pipes and what have you. So it's not advisable because at first it's very exothermic, that is, gives us a lot of heat, and the mist formed, they are highly corrosive and doesn't condense easily. So which of the options matches our explanation? So join me. Option A, acidic gas. Option B, the acid is usually added to water and not water to acid. Option C, the reaction between SO3 and water is violently exothermic. So option C confirms our answer. So we have with us question number 17. Which of the following statements does not show Rutherford's account of nuclear theory? Okay, so at first, the Rutherford is N.S. Rutherford, the physics that you know of. So he gave some theories about the atom, just like a solar system, being orbited around by electrons, okay, with a very small nucleus that is positively charged because it contains proton and neutron. Now take note of this. So okay, I think we just confirmed that. So definitely Rutherford's account of nuclear theory confirms that it contains protons and neutrons just in like the center, okay? That's the nucleus, okay? Which is positively charged. The center is positively charged because neutron has no charge. So it's the proton that carries the charge, okay? Then we have option C, which is massive and can cause deflection of a few projectiles, okay? Let's look at that. Then option D, which is very large and in which close to 98% of the projectiles pass undeflected. Now this is what we should know. Alpha particles just pass through and their trajectory are not being affected most of the time, okay? Because there is no enough charge to repel them or affect their trajectory until they move very close to this nucleus center that is positively charged. So remember that like charges repel. So the positive charge in the nucleus repels the alpha particles, which are very rare, okay? So that is when we now have that option D is still correct, so which is very large and in which close to 98% of the alpha particles, projectiles, pass undeflected. They just move around the atom, okay? So we can see that option C is incorrect, so which is massive and can cause deflection of a few projectiles. So the statement that does not confirm Rutherford's account of nuclear theory is option C. So here we have question number 18. Elements X and Y have electronic configurations 1s2, 2s2, 2p4 and 1s2, 2s2, 2p6, 3s2, 3p1 respectively, okay? So when they combine, the formula of the compound formed is, Okay, so now let's just produce some kind of diagram to help us with the explanation. So in case you still need clarity or further explanation, remember that on the Myschool website, we have lots of solution providers waiting for you to just ask your question. And to help you and make it easier, I've provided a link in the description below where you can ask those questions right now. And within a few moments, solutions and clarity will be provided for you. Okay, so now let's go over to question number 18. So we have the configuration 1s2, 1s2, 2s2, and 2p4. So definitely 2 plus 2, that is 4. 4 plus 4, that is 8. So the element with atomic number 8 is oxygen. Okay, so if you want to put it out, we have 2,6. Okay, so that means it has valency of -2. It needs 2 to complete the atomous shell, okay, to obey the octet rule. Okay, so I can draw something like this for you. This is oxygen. So 1, 2, okay. This is the configuration, 2 in the innermost shell, then the 6 outside. So to become stable, it just needs 2 to complete it. Okay, so we have the other elements mentioned. Okay, we have 1s2, 1s2, 2s2, 2p6, 3s2, okay, then we also have 3p1. So if you add up, this is 2 plus 2, that is 4, okay, plus 6, that is 10, plus 2, that is 12, plus 1, that is 13. So the element with atomic number 13 is aluminium, okay? So we have aluminium, and it has a valency of 3. So it can give out 3 electrons, okay? So you can have your configuration as 2A3. It can give out. So if I want to draw something like this, okay, this is all filled up, okay? Okay, so I have something like this. Okay, so 2A3. So it can give out 3 valence electron, and this is ready to accept 2. So for them to be able to match properly, like to form a compound, so that means, and this is labeled element X, sorry, element, okay, element Y, and this is element X. Okay, so for them to come together, let me have clarity. So we have element X, okay. All right, so when you look at this closely, this is element X and element Y. So for them to come together, that means this needs 2, this can give 3. So let's balance it. So that will be X, we need 3. That is 3 times 2 gives you 6. Y can give out 3. That means 3 times 2 will give you 6. Okay, so 3 of this we need. The valency is 2, that is 2 times 3 equals 6. The valency of this is 3, that is 3 times 2 equals 6. Okay, so this is their valency, and this is what they need to combine together, 3, okay, and the 2 to form the compound we are talking about. So your formula for the compound is X3Y2. So let's go through our options together. So we have option C. So here we have question 19. By what amount must the temperature of 200 cm³ of nitrogen at 27 degrees Celsius be increased to double the pressure if the final volume is 150 cm³? Assume ideality. Okay, so this is ideal gas equation. Okay, and that is P1 V1 over T1 equals P2 V2 over T2. Okay, so if you refer to the question, we are asked that by what amount must the temperature be increased. So definitely we are looking for T2. So let's make T2 the subject of the formula. So if you cross multiply, we would have T2 into brackets, what we have here, P1 V1 equals P2 V2 into bracket T1. So without minusing words, that means this coefficient here divides both sides, okay? So I would have over P1 V1 over P1 V1, okay? So this is gone. So that means this is the formula for T2, okay, the second temperature we are asked to solve for. So now let's find out the values of each we have. So T1 is giving us 27 degrees Celsius. Bringing into Kelvin, that means you are adding it to 273, and that gives you 300 Kelvin. Okay, so going to P1, that is just one of itself, okay, and P2, we are told that is times 2, double of the pressure, that is 2 of P1. Is that okay? All right, so we also have V1 giving us 200 cm cube, and V2 as 150 cm cube. Okay, very well. So now let's slot in our values into the formula we have here. So definitely we would have P2 times V2. So P2 is 2 of P1 times V2, which is 150, okay, times T1, which is 300, over P1 V1, okay? So P1, that is one of itself, times V1, which is 200 cm cube. Okay, so, all right, so we still have 3, we have 2. Okay, so one of these, so we are left with 2. 2 strikes out 2. So we have on the numerator, we have 3 times 150, that gives you 450. So T2 is 450 Kelvin. Okay, so bringing it back to Celsius, that will be minus 273, and that should give you 177 degrees Celsius. So the question reads that by what amount must T1, and T1 is 27, so by what amount must T1 be increased? So that is, what is the difference between T1 and T2? So that will be 177 minus 27, and that is 150 degrees Celsius. So we have to increase T1 by 150 degrees Celsius to get T2. So the correct option is A. Here we have question number 20. The combustion of carbon 2 oxide in oxygen can be represented by the equation 2CO plus O2 to give you 2CO2. So we are asked to calculate the volume of the resulting mixture at the end of the reaction. If 50 cm cube of this was exploded in 100 cm cube of oxygen. So join me as we go to our drawing board to provide solution to this question. Okay, so this is the equation we have here. I just replicated it. Okay, very well. So let's look at the volume ratio of each of the compounds here. So I would have the volume ratio here. I'll represent it with VR. This is 2. Okay, 2 of these react with 1 of these, okay, to give us 2 of these. I think you can see there. All right, so we are told that 50 cm cube of this. So this is what was brought before the reaction, before the combustion, okay? So 50 cm cube of this actually reacted with 100 cm cube of oxygen. So this is before the reaction, so definitely the value here is 0, okay? All right, so now in the course of the reaction, when the combustion happened, okay, the explosion, when CO was exploded in oxygen, so in the course of the reaction, so let me call this dr during the reaction, okay? So 50 of this, so you can see the volume ratio. If 50 of this is present, definitely it's going to react with 25 of it, just half of it, okay? So that is in the reaction, 50 of this react with 25 of this. This is also 2, so we are going to have 50, okay? So after the reaction, so what would have, just look at the difference. So 50 of this was brought in, 50 of this was used up, so we have 0 left, okay? All right, so in the course of the reaction, we brought in 100 of this, but we only used up 25. So what is left is 75, okay? So when we look at the product side that we got, the resulting gas, the difference is still 50, Okay, so when we look at after the reaction, the resulting gas will be 0 plus 75 plus 50. So definitely your answer is 125 cm cube. Okay, so let's go to our options. So option B is correct. Now to question number 21. When ammonia and hydrogen ion bond together to form ammonium ion, the bond formed is actually called a covalent bond. Although 3 of the bonds formed, they are covalent, and the 4th bond that is formed is referred to as coordinate bond or dative covalent bond. This is due to the movement of hydrogen from the chlorine atom, okay, from the chlorine ion down to the nitrogen. So the movement of hydrogen is actually the cause of all of these types of bonds. So basically, the kind of bond formed in ammonium ion, there are 2. Okay, we have 3 covalent bonds, okay, and the dative covalent bond or the coordinate bond. So the correct option that fits the question here is option D. So in case you have 1 or 2 recommendation or suggestion on how we can improve or better answers to any of the questions so far, don't forget to indicate the number and your recommendation in the comment section below. So before us, we have question number 22. Okay, so which of the following represents the kind of bonding present in ammonium chloride? So you will recall that in ammonium itself, it has 2 types of bond. It has a covalent bond. 3 of it are covalent bonds, and the 4th one is a dative covalent bond or a coordinate bond. So in ammonium, we have covalent and dative covalent. Okay, so the coming together of ammonium and chloride forms an electrovalent or an ionic bond. So bringing them together, that means in ammonium chloride, the types of bonding present are ionic or electrovalent, as you may call it, and covalent. So option C is correct. All right, so we have question number 23. Consider the reaction. A solid plus 2 moles of B, gaseous, okay, gives you product of 2 moles of C, aqueous, plus D, gaseous. So what will be the effect of a decrease in pressure on the reaction? So what will be the effect of decreasing pressure on the reaction? So don't forget that change in pressure only affects gaseous reactants, okay? So looking at this, anytime we decrease pressure in a system, it actually favors the side with more particles, okay? And on the reverse side, once we increase pressure, definitely volume will decrease and it's going to favor the side with less particles, okay? So when we look at this reaction very well, okay, we have 1, we have 2, that makes it on this reactant side, we have 3 particles, okay? So to the product side, we have 2, we have 1, that is 3. So you can see on both sides of the reaction, we have 3, 3. So the number of reactants equals to the number of particles of reactants equals the number of particles of product. So definitely decrease in pressure, we have no effect. So option D carries our answer. The rate of forward and backward reactions are not affected. So I believe you are enjoying this content and you would like me to bring you more of it. So don't forget to hit the like button, click on the subscribe button and tap on bell notifications to get informed as we release the next videos. Okay, question number 24. For the general equation of the nature xp plus yq, that's a reversible reaction, okay, mr plus ns, the expression for the equilibrium constant is, so let's first replicate the equation that we have. So this is the equation that we have in our question, okay? So equilibrium constant, that's very easy. So K, okay, will be equals the products over reactants, okay? Over reactants, okay? The coefficient of product over reactant. So when you look at it, whatever coefficient that is standing beside each particles will become their power, okay? So At the top, we have product for the numerator. So the products we have, they are R and S. So this is their coefficient. It will turn to their power. So when we look at the first product, which is R, so definitely its power will be its coefficient, which is M, okay, plus when you look at the second product, okay, which is S, its power will be N, okay, N rather, over our reactant, okay, we have P, its power will be X, okay, plus we have the second reactant, which is Q, which its power will be Y. Okay, so let's go through our options and see which fits what we have here. Okay, so we can see that option, look at it, R raised to power M plus S raised to power N, P raised to power X, and Q raised to power Y. That makes option D the correct option. Okay, so we have question number 25. Which of the following reactions is an oxidation process? So recall that oxidation process means the loss of electron, reduction means the gain of electron, okay? Oxidation process means removal of hydrogen, reduction means the opposite. So when you look through all of our options, there is actually loss of electron in one particular option, and that is option D. 2 moles of oxygen ion, okay, plus 4 moles of electron. You can see that there was loss of electrons. So option B is correct. So don't forget to prepare and practice using our simulated JAMB CBT past question mobile app and software. So we have the JAMB CBT past question for mobile app, which is called the Myschool JAMB CBT for your mobile app. We also have the Myschool JAMB CBT exam for your software on your computers, laptops, and what have you. Here we have question number 26. If acidified potassium dichromate 6 acts as an oxidizing agent, the color changes from, so normally the dichromate ion is responsible for the orange color of potassium dichromate 6. So when it is acting as an oxidizing agent to a primary alkanol, it first converts it to an aldehyde, but under certain conditions directly to a carboxylic acid. So in this whole reaction, if it's for a secondary alkanol, it's converted to a ketone. So for this kind of setting, so we know originally that the dichromate ion is responsible for the orange color of potassium dichromate 6. So the color change will be from orange to green. Okay, option B. So we have question number 27. The heat of formation of ethene C2H4 is 50 kilojoules per mole, and that of ethane C2H6 is minus 82 kilojoule per mole. Calculate the heat involved in the process. So we are asked to look for the enthalpy change of the reaction, okay? So remember that in every reaction there is a system and there is a surrounding, okay? So whenever heat is being released from the system into the surrounding, that means heat energy is given off, that makes the reaction negative, exothermic. X is given. But anytime heat or energy is being absorbed from the surrounding into the system where the reaction is taking place, that makes it an endothermic reaction, because there will be decrease in the temperature of the surrounding compared to the system. So let's look at the values we are given. So enthalpy change, the enthalpy change equals the product minus delta, then the reactant, okay? So for the product, we have minus 82, okay? Then for the reactant, we have 50. Okay, so now let's see this. So we have minus 82 minus 50, so your answer will be minus 132. So definitely this is an exothermic reaction. We can put our units, okay, to power minus 1. This is an exothermic reaction. So let's go through our option and see which one is correct. We have option B. Here, question number 28. Which of the following statements about catalysts is false? A. Biological catalysts are called enzymes. Of course, enzymes are organic or biological catalysts. So, A is correct. So, B. Catalysts do not appear in the balanced equation. Okay, that's correct. So, that means it's not false. C. Catalysts reduce the activation energy for a reaction. You know, activation energy is that amount of energy that the reactant must possess for them to be able to form product or for the reaction to take place. So definitely what catalysts do is that they lower the activation energy, or they probably provide an alternative mechanism for the entire reaction. So when we look at option D, catalysts do not alter the mechanism of the reaction and never appear in the rate law. So we know that catalysts at first, they reduce the activation energy and they also alter the mechanism of the reaction. So we see option D is false about catalysts. So in case you have questions you would like to ask and you want to ask them right now, I've provided a link in the description below that will take you to the Myschool website, where there are army of solution providers that will attend to your questions within minutes. Question 29. Okay, so which of the following does not support the fact that air is a mixture? So looking at A, the constituents of air are in a fixed proportion by mass. Of course, the constituents are fixed by mass, although the composition of air in various places differ. Okay, so but definitely they are fixed by mass. Okay, now let's look at option B. It cannot be represented with a chemical formula. Of course, air cannot be represented with a chemical formula because the composition differs from place to place. Okay, let's look at C. The constituents of air can be separated by physical means. Very well. These constituents can be separated by physical method. Okay, just take for instance, you take air, then you put it into a big space, then you allow it to escape through a small aperture. You realize that at a certain point it turns to a kind of liquid and you can collect the different constituents by fractional distillation. You can see more of that from your textbooks and other resources. So if you go through all of these options, you see that they support the fact that air is a mixture. So D, none of the above, is our answer. Question 30. What technique is suitable for the separating a binary solution of potassium chloride and potassium triazochlorate 5? Okay, so what is fractional crystallization? That means when we have two solutes in a given solution, okay, so at different temperature, probably on cooling, one of the solutes will pop up, leaving the rest behind. Okay, so we have fractional distillation, that is for mixtures, and you want to use difference in their boiling point to get the required liquid. Okay, so we have filtration, that is separating a solute from a solution. For example, a piece of chalk in water, you can use your filter paper to carry out filtration. Then we have evaporation, that is use of heat to dryness. Okay, so we have looked through the options. So definitely fractional crystallization fits what we have here. So option A is correct. So that is it for this segment, but there is definitely more to come. So I will tell you, hit the like button, click on the subscribe button and tap on bell notification so that you can get informed as we release the next videos for the question of this year.